Hi everyone, hope all of you are doing well. In this video, we are going to talk about hypothesis testing for a population proportion. So let me remind you about proportion a little. So, a proportion is a fraction or a percent of a sample or a population having a particular trait of interest. Okay, so for the population proportion, we use P, okay? P is population proportion. And for the sample proportion, we use P bar, okay? So if in a sample, we look for the fraction or the proportion of items having a trait of interest, we use P bar. For example, if in a classroom, there are 10 students, in total we have 10 students, and out of these 10 students, just 5 of them wearing glasses. The proportion of the students wearing glasses would be 5 out of 10, or half, 50%, okay? So look at here. X is number of items in the sample having the trait of interest. For example, in the example, I told you trait of interest is wearing glasses, okay? We have a sample of 10 students in the class. X number of students with the trait of interest wearing the glasses is 5, okay? So what is the proportion of the students in this class wearing glasses? 5 out of 10, or half, okay? So just I try to recall you about sample proportion and population proportion, because we are going to do a hypothesis testing for a population proportion. Okay, but let me remind you about the steps also in hypothesis testing. Look at here, in any hypothesis testing. In step 1, we need to formulate null and alternative hypotheses, H0 and H1. In step 2, we need to select a level of significance, alpha. Okay? Alpha, or probability of making type 1 error, or very simple, alpha is the area of the rejection regions. Okay? In step 3, I need a sample. In step 4, I need to identify the rejection region clearly. And in step 5, I need to calculate a test statistic. Here for the sample proportion, I need to find the test statistic for the sample proportion here, because I'm going to do a hypothesis testing for proportion. And in step 6, we decide about rejecting or not rejecting the null hypothesis. Okay, so look at it in step 5. In hypothesis testing for a population proportion, if the binomial conditions fit and n times n is sample size, p is population proportion. If the sample size times population proportion is more than or equal to 5, and if the sample size more than 1 minus population proportion also is at least 5, then I am allowed to use this formula to find the test statistic of P bar. Okay, so in step 5, in hypothesis testing procedure, to find the test statistic, to calculate the test statistic, I'm going to use this formula. But first, we need to check if the binomial conditions fit. Okay, I'm going to explain that on a question. So look at here, in Z formula, P bar is sample proportion, P is population proportion, N is sample size. Okay, let's solve this question. I'm going to do a hypothesis testing for a population proportion. In this question, I'm going to use two approaches: hypothesis testing approach and p-value approach for this question. First, let's read the question. question says a report stated that at least 45% of the persons employed this year are doing side business for the last 5 years. Look at here, it's the proportion or percent of the persons employed this year and doing side business for the last 5 years. A sample of 300 employed persons this year showed 84% were also doing another business within the last 5 years. Okay, look at it. We have sample of 300 employed. Shall we reject the claim at 0.01 significance level? Alpha is 0.01. Look at here. First, I need to check if the binomial conditions fit. Okay, if you remember, in a binomial experiment, we always have a fixed number of trials. Okay, here I have a sample of 300 employed persons. Okay, they are trials. We have n is 300, number of trials. Okay, for each trial in a binomial experiment, for each trial, we always have two possible outcomes. One of them is failure, another is success. Okay, so look at here, what is a success in this question? If the employed persons, okay, if the employed persons are doing another business within the last 5 years, that's a success. Otherwise, that would be a failure. Okay, and what is the probability of success? Do you remember in a binomial experiment, we need to have the probability of success. Okay, so probability of success is 45%. Okay, it's the probability of the persons employed this year and doing side business for the last 5 years. So it's probability of success in this experiment. Okay, and trials are independent. So the conditions of binomial experiment fit here. Okay, and also look at here, I check the binomial conditions for the question. Also, I need to check if np and n times 1 minus p are more than 5. Look at here, n is how much here? N is 300. P, population proportion. Look at here, we have a proportion of persons employed this year. Okay, we have a population of persons employed this year, and 45% of them are doing side business for the last 5 years. Okay, it's the population proportion, P. Okay, just I need to check if NP, N times P, is more than 5, equal or more than 5, and also N times 1 minus P. If I multiply 300 by 0.45, we get 135. Okay, it's definitely more than 5. And also, N times 1 minus P. Okay, N is 300. N is 300. 1 minus P, 1 minus 0.45 is 0.55. 300 times 0.55 is 165. So also it's more than 5. Okay, so I check these two conditions and they fit in this question. So I am allowed to use this formula, Z formula, to find the test statistic for the p-bar, sample proportion. Okay, so now I'm gonna do the hypothesis testing step by step in this question. So look at it in step 1, in hypothesis testing procedure, in step 1, we always need to formulate H0 and H1. Okay, so step 1. Okay, in step 1, I need to formulate H0 and H alternative. Look at here, there is a claim in this question. A report claims that at least 45% of the persons employed this year are doing side business. Okay, so let's write the claim as a math expression. It says at least 45%. That's the proportion of the persons employed this year and doing side business for the last 5 years. Okay, so it says proportion or P, population proportion, at least is 45%. Okay, let me write here. P is at least 45%. Okay, look at here, that's H0, null hypothesis. Why? Because I have equal sign. Okay, so that would be H0. We already made H0. But what about H alternative? H alternative is population proportion is less than 0.45. So if you remember, we need to cover all the possible values for the population parameter here, population proportion. Okay, if H0 says P is at least, H1 says P is less than 0.45. Okay, so it's a step 1. Now a step 2. In step 2, I need level of significance. Level of significance in this question, alpha is 1%, 0.01. Okay, 0.01, it's alpha. In step 3, I need a sample. So step 3, we need a sample. Look at here, in this question, we have a sample of 300 employed persons. Okay, so sample size is 300. Okay, and this sample of 300 employed persons showed 84% were also doing another business within the last 5 years. Okay, look at here, rate of interest is doing another business within the last 5 years. Out of these 300 employed person this year, 84% doing another business within the last 5 years. Okay, so X number of items with the particular rate of interest is 84. Okay, so as a result, P bar, sample proportion would be X over N, or 84 divided by 300, so we get 0.28. Okay, it's the sample proportion. So in step 3, we summarize the information about the sample. Now in step 4, I need to identify the rejection region clearly. So step 4, we need to identify the rejection region clearly and check if the Z value of P bar sample proportion falls within the rejection region or no. Okay, look at here, look at H alternative. In H alternative, P is less than 0.45. So here I have a one-tail test. Here we have a one-tail test because we don't have equal sign and not equal sign. We have a one-tail test, and tail is on the left side. Okay, because an easy way to find if the tail is on the right side or left side is to look at H alternative. P is less than, so tail is on the left side. If it was more than, H alternative, tail would be on the right side. So we have a tail on the left side. Okay, the rejection region is on the left side. So far I know the rejection region is on the left side. I'm trying to identify the rejection region clearly. Okay, so Look at here, I need to identify the rejection region clearly. I need this cutoff point. Okay, look at here. I have the area of the rejection region. The probability that a z value, a z falls on the left side of the cutoff point is 0.01, or very simple, the area of the rejection region is alpha. Okay, the area of the rejection region is alpha. Alpha is how much? Alpha is 0.01. Okay, so now I know the area of the rejection region is 0.01. I know the rejection region is on the left side. Just I need the cutoff point. Just I need this cutoff point. To find this cutoff point, just I need to go to the Excel, and by using norm S inverse, okay, norm S inverse, I can find the cutoff point. Let's go to Excel to find the cutoff point. Look at it, it's the Excel file for the same question. We have a one tail test. Tail is on the left side, okay. X, the number of items with the particular trade of interest, okay. Doing another business within the last 5 years is 84. We have a sample of 300 employed persons. Population proportion is 0.45. Alpha level of significance is 0.01. We got the sample proportion 0.28. 84 divided by 300, it's the sample proportion 0.28. We need to find the cutoff point, okay? I know the area on the left side of the cutoff point is 0.01. Just by this function, norm S inverse, then alpha, I can find the cutoff point. The cutoff point is minus 2.33. Let's back to the slide. So this cutoff point is minus 2.33. Okay, so step 4 is done. I have identified the rejection region clearly. Now let's do step 5. In step 5, I need to find the z value of p bar. So step 5, I need to find the z value of p bar, sample proportion, by this formula. Z is p bar minus p over p times, it's bracket, times 1 minus p over n. Look at here, this formula, p bar minus p over square root of p times 1 minus p over n. Okay, so it's a complicated formula. Let's do that in Excel. P bar is how much? P bar is 0.28, p is 0.45, and n is 300. Let's go to Excel. Look at here, z is here, it's z. But to have an easier calculation, first I'm gonna find the denominator of this fraction, a square root of p bar over I'm gonna find first a square root of p times 1 minus p over n. Okay, so let's do that here. Then I'm gonna find p bar minus p divided by this one. So a square root of p times 1 minus p, then divided by n. Okay, so look at here, a square root of p times 1 minus p divided by sample size. It's 0.03. Now let's find z, this one. Okay, so to find this one, so I need to find p bar minus p. P bar is 0.28 minus p 0.45 divided by 0.03. Okay, oh, sorry, I forgot to divide. Let me try one more time. Look at here. So I need p bar minus p, then close the bracket, divided by 0.03. Okay, that's z. Z value of P bar is minus 5.92. Look at here, let's back here. So look at here, the Z value of X bar, the Z value of P bar is minus 5.92. Let's check one more time. Yes, minus 5.92. So minus 5.92 is less than minus 2.33. It's on the left side of the cutoff point. Cutoff point is minus 2.33. Z value of P bar minus 5.93 is on the left side of minus 2.33. So Z value of P bar falls within the rejection region. P bar falls within the rejection region. So we reject H0. Okay, so here in step 6, I need to make a conclusion. What is the conclusion? Step 6. So Z value, let's write the conclusion. So Z value of P bar falls within the reject region. So we reject H0. H0 was the claim. Okay, a report claimed that at least 45% of the persons employed this year are doing side business for the last 5 years. Now we concluded that we reject this claim because we rejected H0. H0 was the claim in the question. So we reject H0. So when we reject H0, what is the conclusion here? So this number 45%, this statement, this claim that at least 45% of the persons employed this year are doing side business for the last 5 years is not correct. Okay, we reject that. We reject the claim. So the claim will be rejected. Okay, so by hypothesis testing approach, I rejected H0. We can solve the same question by p-value approach. I can make the same conclusion by the p-value approach. Okay, so to solve the question by p-value approach, because the tail is on the left side, to find the p-value, I'm going to use the probability of observing a z value from the standard normal distribution, which is at most equal to this z value, minus 5.92. Okay, I need to find the area on the right side of minus 5.92. By which function? The area on the left side, sorry. Here I need to find the area on the left side of minus 5.92 because look at here, z is less than or equal to z. Okay, I'm looking for the probability of observing a z from the standard normal distribution, which is at most equal to minus 5.92. And okay, because that z value is on the left side of minus 5.92, I need the area on the left side of minus 5.92 by using norm, okay, norm standard distribution of minus 5.92 and then cumulative. We can find the p-value. Look at the p-value. P-value is very small. It's almost zero. What is the conclusion? When p-value is small, it's almost zero. P-value is less than alpha. Alpha is 0.01. P-value is less than alpha because p-value is very small, almost zero. So we reject H0. By the p-value approach also, I concluded that I need to reject p-value is less than alpha, so we reject H0. And also by this method, by the normal hypothesis approach, I also rejected H0. So we solved this question by two methods, and the conclusion was rejecting the claim.